One of the things that we're interested in when we look at data is taking a look at potentially two different things, like, say, coffee consumption and heart health, and seeing how those two things are related to one another. One of the worst things that people do with data is assuming that any relationship we find between the two is a cause and effect relationship. And it's not necessarily that. Rather, we know that the two variables are associated with one another. We know that they're correlated with one another. You may have even heard the phrase, correlation is not causation. That means that you can have two variables that are related to one another, that are correlated, without there necessarily being a cause and effect relationship. Now, most of the times when we run a study, we are, in fact, wanting to have some kind of cause and effect outcome. However, most of our studies actually set us up only to have a correlation outcome. One example of a type of study that we might conduct is an observational study. In an observational study, we might go out and take a survey of people. So I might stand on a street corner and ask people, how much coffee do you drink every day? And have you had any issues with your blood pressure, cholesterol, any heart problems whatsoever? And I might be able to look at those two and find some kind of correlation between the two. However, if I do, I haven't at all found a cause and effect. So that's an observational study. Another type of study is a clinical study. In a clinical study, what I do is I try to put things together in such a way that I can be a little bit more sure that there might be a cause and effect relationship there and not just correlation. So a clinical study is really interested in making sure that anything that would be a confounding variable is controlled for. Now, confounding variables are like that third variable that might actually be causing things. For example, we might see more shark attacks in the summer months. So we might say that shark attacks are caused by the summer months. Well, that's maybe not necessarily actually true. It might be that there are more people at the beach in the summer. So it might be that the people are at the beach more in the summer, so there are more people out there to potentially experience a shark attack. That would be an example of a confounding variable, the number of people at the beach when I'm looking at the months versus shark attacks. So whenever you're looking at a study and evaluating how good it is, you really need to be thinking about what confounding variables might be out there. One type of clinical trial is called a control study. In a control study, we're going to collect a sample of people and then randomly assign them to one of two groups. So our two groups, one of them is going to receive a treatment and the other one is not. And then we're going to study the outcome. In doing so, we are trying to control for the confounding variables by saying we have this random group of people and there may be other things at play, but half of them are getting this one treatment. The only difference between the groups, other than the little things between person to person, is that they're getting this treatment or they're not. So this is happening with drug trials a lot. We have drugs go through these clinical trials and they go through this control testing where we have a control group and a treatment group. And then we can actually say, it seems the group that had the treatment performed better or worse than the group that didn't. And so there's a little bit more evidence there than for a cause and effect relationship. However, you still should be very careful to assign cause and effect relationship to anything. Now, sometimes in a controlled study, the people who are in the groups don't know which group they're a part of. So they don't know if they're receiving the treatment or not. In this case, the study is called a blind study. Now, there are other studies where both the participants don't know which group they're a part of and the researchers don't know which group they're a part of. The assignment is done in such a way that both the researchers and the participants remain blind as to which group they are in. That study is called a double-blind study. And that eliminates even more possibility that the people doing the research are influencing the outcome in any way. Now, in order to accomplish this, say with a drug trial, you have to give people a pill to take, whether it's the real drug or not. So the control group receives what's called a placebo. And a placebo is something that may look like the actual drug, but it's not. It's fake. It's a sugar pill usually. So some people actually experience the things that are supposed to be benefits of the actual drug when they take the placebo. That's called the placebo effect. If they believe deeply enough that they're receiving some kind of benefit from something, then sometimes their body will mirror that they actually are receiving that benefit. And that can be a thing that makes studies kind of challenging at times. So if you take anything from this, please take the idea that cause and effect relationships, establishing those, is actually a very rare thing to do. So most studies are actually going to be establishing correlation rather than causation. And anytime you see reports otherwise, you should be skeptical.